All right, welcome to our discussion on how to draw ray tracings for lenses. We're going to first start off with the basic convex lens with an object beyond the focal point away. Keep in mind when you're doing ray tracings that you always want to make sure you have a good setup, and the first rays that we draw always come in parallel to our principal axis. Now keep in mind, when it strikes a lens, remember that the light ray will bend both when it hits the glass coming from air, and it would bend again when it comes out of the glass back into air. So to negate this, we just simply draw it to the middle of the lens instead. Once we have our line parallel to the principal axis and it strikes our lens, it will bend and go through the focal point on the opposite side. Your second ray then will appear to go through the focal point on the same side, strike again in the middle, and exit parallel to the principal axis. Then our last ray, and this is a little bit different than mirrors, the last ray just goes straight through and is not bent because it's assumed that this is roughly parallel both sides, so there would not be any sort of deviation there. Where the lines intersect, just like we had with mirrors, our image forms. And a little bit different now on the opposite side because you're looking through the lens. That makes this a real image, could be cast onto a screen. It's obviously upside down or inverted. It is bigger than the original object. And its location is farther away, again on the opposite side, making it a real image. If we then change and we move our object onto the focal point, we again start with our first ray parallel to the principal axis, bend it through the focal on the opposite side. This is where it gets a little bit tricky because you would say the second one, well, how are we supposed to put it through the focal point? Well, we just don't have that in this case because we can't do it. So we then go with our third ray straight through the middle again, and as you'll notice, those two are parallel to each other, so we would not get an image. Therefore, no image formed, and we can't really give you anything for it. All right, now what happens if we keep moving that thing towards our lens and we now get it inside of the focal? Same rule for the first one, goes parallel to the principal axis through the focal point on the opposite side. Our third ray again here, straight through the middle. And we come in with through the focal and parallel. Now again, you would look at this and go, well, those are all diverging, we're never going to get anything. Keep in mind, we want to then take these rays and go back from the line that we drew into our virtual side, or on the same side as the object. And if we extend all three of those, again, the point where they intersect is where we get our image. This is going to be a virtual image then because it's on the same side. There's no way that we could project this onto a screen, and the real rays on the right side are diverging. They're never going to come together. So if the real rays don't come together, you can't get a real image. You can tell that it is upright, you can tell that it's bigger, and again, farther away from the lens. Everything is measured either from the lens or from the principal axis. Since we're talking about how far away this is, we're talking about how far it is from the lens. Okay, let's change it up, and let's talk about concave instead of convex. Well, the rules of the rays are still the same. You start with one that goes parallel to the principal axis, but remember, this is a different type now. This is a concave, which means it's going to be a diverging lens. So you're going to go to appear from the focal point on the same side. Again, the next ray straight through the middle. We aim for the focal point on the opposite side this time, and it goes parallel. And again, because this is diverging, we have to do the part where we extend the ray backwards, and where they intersect, we get our image. You can tell again, it's on the same side, therefore virtual. It's still upright. This time it's smaller, but it's closer to our lens this time. Okay, concave again, still beyond F. We've done some mirror tracing, so this should be pretty quick for us. First ray hits the mirror, parallel, or it comes parallel, hits the mirror, reflects through the focal point. Next one through the focal point and reflects parallel. Again, this is the ray that we didn't do. The third one, where it's again equal angles, law of reflection, and again where they intersect. Don't worry about that blue ray, we don't do much with it. You can already again tell all of these things we went through before. It's a real image, it is inverted, it is smaller, it is closer to the mirror, and again on the same side. Because these are mirrors, remember, that makes this a real image because it's on the same side. That's how you tell the difference. A lens, remember, in order to be real, have to look through because the light would all go the way through it. A mirror, remember, it reflects off. So again, continuing on with concave mirrors, this time we put the object at F. First ray always goes parallel to the principal axis and then comes through F. Remember, we talked about the fact that this blue ray is one that we didn't really necessarily talk about, but again, it comes in, strikes where the principal axis intersects, and then you notice that it comes out parallel, which is again going to tell us those are parallel to each other. They will never meet, therefore no image can be formed. Next, if we move inside, we've talked about these a little bit, but again, same thing, parallel, comes out through the focal point. We go from the focal point and exit parallel. You'll see again, these are diverging. Keep in mind again with a mirror, it's going to reflect off instead of the lens where it would go through. So again, we have to extend these backwards inside of what we would call the surface of the mirror or behind the mirror. And again, where they intersect, you have your image formed. You can tell this is going to be on the opposite side of the mirror, therefore a virtual image. You can see that it is upright. It is definitely larger, and it's a little bit farther away. So for a convex mirror, we would have our object giving off again a light ray parallel to the principal axis, bouncing off as if it came from the focal point. We aim one for the focal point, have it reflect off parallel, and again this blue one that we didn't necessarily do, just has to be equal angled. When we draw them, you don't have to include this blue ray. Again, we would extend these with our virtual back into the surface of the mirror. Where they intersect, you can tell your image forms. Again, going to be virtual. Convex mirrors always create virtual images because they again are diverging mirrors, which means when the light strikes and it bounces off, the rays diverge from each other, which you can tell the real rays on the right side of the mirror here are all diverging from each other. You can see that the object got smaller and it is closer. This is why on your driver's side, or sorry, passenger side mirrors, it always says objects in mirror are closer than they appear because they always look smaller and they always look like they're closer. So they have to put that little warning in there for you. If you have any questions, make sure you talk to your teachers. Otherwise, go ahead and work on your practice.